Okay, well, this should be Georgie and this should be Olivia for pre-algebra. This is your first online YouTube lesson for math. So I want you to check a few things before we get started. Make sure that the date that you're watching this video is the correct lesson. So March 30th, 3/30, 2020. Your video should say pre-algebra, and then it should have a lesson, and we talked about that in our daily video, but the lesson for today for you guys, don't panic, is chapter 12 test. Now before we get started with that, I realize that you guys have been off for 2 weeks, and I realize that it would be incredibly cruel for me to give you a test over something that you haven't looked at for 2 weeks. So what I thought we'd do today is we're going to do a quick review through chapter 12. I'm just going to refresh you so you go, oh yeah, I remember that. Okay, and then what I want you to do is I want you, in your folder, you already have the chapter test in there and copied. So I want you to take that out, and then today you're just going to do it like it's a math worksheet. Okay, so basically it's open book. You can ask for help and make sure that you use Marco Polo. Ask me for help on those. And then you're just going to do it like a normal worksheet, okay? It'll just be a daily grade. It's not going to be a test grade, and you don't have to know everything that's in there because I realize that's kind of hard. So I hope that that puts you at ease. So we're going to get started, and I'm just going to review some of the basic concepts that we've learned, and then that might help you as you go forward and kind of work through this. So back at 12.1, we started with basic geometry. We talked about a point. We talked about a line. Remember, it has the arrows on the end. It says it goes forever in both directions. We talked about a line segment. It's just taking a piece of that line out, right? And so it doesn't go on forever in each direction. We talked about a plane. A plane is the flat space that we work on, and it's labeled as well. It has points on it as well. I think you guys have pretty well got that. That's not the kind of stuff, pretty basic, that will be on your test. The next thing we're going to talk about is we talked about measurement of angles and the different types of angles, and that's really important. So I'll review that really quickly with you. So when we put, remember if we had two rays, remember, and we put them together, then boom, we have an angle. Okay, so remember, 90 degrees is kind of the test point of an angle. So if we were to take our protractor out and we were to make an angle that was 90 degrees, we would see it would make a perfect square, right? So this is a 90-degree angle. Okay, so what I want you to remember is a 90-degree angle is a what? A right angle. Okay, it's a right angle. So when we look at this angle, we say, well, I can clearly see that we can't make a square out of that. It's smaller than an angle. a 90-degree angle. So what do we call an angle that's less than 90 degrees? Acute little angle. Acute angle. So acute because it's less than 90 degrees. Okay? And then if I look at this angle, and I say, wow, I can't make a square out of that angle either. It's bigger, the angle is bigger than 90 degrees, right? So if it's greater than 90 degrees, do you remember what we call this one? Obtuse. It's an obtuse angle. So those are our three different kinds of angles. And these are really important because remember we start to call triangles obtuse triangles, acute triangles, right triangles as we get farther on into the lesson. Okay, so I'll keep going. From there, we talked about some of the really cool things about a triangle, that no matter what the shape of the triangle is, let's do it like this. What do all the degrees add up to equal? Do you remember? Okay, 180 degrees. So if I added this angle, and this angle, they would all equal 100. If I added this angle, and this angle, they would equal 180 degrees. And a little right angle in there, 180 degrees. Okay, so remember that. That's really cool, isn't it? That all triangles always equal 180 degrees. So if we're given two angles, we can add them together, subtract them from 180, and get our third angle. Okay, so I think you guys were pretty good at that and had that figured out. I'm going to move on to the next one. The next one where we talked about pairs of angles. We talked about complementary and supplementary. Now, for your notes, remember that complementary angles are two angles that are side by side. But if we added both of their measures up, they would equal 90 degrees. Okay? They complement each other. So let me just do a little picture of this. So here I have an angle, right? And if I were to look at the angle as a whole, I can see that that's a right angle. And we know a right angle equals 90 degrees. Okay? So I could say that the measure of this angle plus the measure of this angle will equal 90 degrees. So complementary angles are simply two angles that added together equal 90 degrees. Okay? Now, the other one was supplementary angles. Okay? And supplementary angles equal 180 degrees. Okay? So what that means is I have two angles. Now let's do this angle. Then I have an angle that joins it. So here I have this angle and I have this angle. When we look at the thing as a whole, we can see that it's a straight angle, which we've talked about being 180 degrees. But I can see that if I were to add these two up, it would be 180. Okay, so if this one was 60 degrees, well, what would this angle need to be? I hope you're saying, well, that would be 120 degrees to equal 180 degrees in all. Complementary angles, supplementary angles. Okay. I'm going through this really quickly because, like, again, I said it's a review. I think it'll be really good for you to open that practice test up that you have today and work through it and see what you remember and what you don't remember. Okay. The next kind of angle I want to talk to you about are vertical angles. I don't know if you can remember what those are, but they're pretty fun. So if I had two lines that intersected, okay, if I have two lines that intersect, whoops, I hope you can see that. Let me make that a little bit darker. There, hope that's a little bit easier to see. So I have two lines that intersect. Vertical angles are kind of the same as saying opposite angles. Okay, so what I know about this one is that this angle will always equal the measure of this angle because they're opposite angles. When lines intersect, those opposite angles, or vertical, let's remember the vocabulary word, vertical angles will be equal. Okay, so this is something really cool that I can do. All right, I can say that this measure is 60 degrees. Let's just say it's 60 degrees. Okay, well, if I know that this one's 60 degrees, what do I know about this angle? Well, it's a vertical angle, so it's 60 degrees. What's something else that's really cool? Well, I see a straight line. Okay, so if I see a straight line right here, okay, let me do this with my red. I want you to kind of see what's happening here. I have this straight line, and we know that a straight line is 180 degrees, right? So this angle and this angle are supplementary, okay? And supplementary angles equal 180 degrees. So I can figure out the measure of this angle, okay? 180 minus 60 is 120 degrees, okay? Well, what's the opposite or vertical angle from this one? 120 degrees. So whether I add these up to equal 180 or these, I can also see that the vertical angles are equal. Okay, so you can do a lot with just one measurement in intersecting lines. Okay, so I hope that refreshes your memory there. Let's talk about really quickly before we move on. I think you guys probably already know this, but if two lines are running in the same direction forever and they don't touch, what do we call those? Parallel lines. Okay. Intersecting lines, like kind of what we were just working with. And then we have special intersecting lines, which are called perpendicular lines. And remember, they form all right angles. Okay, so if it forms a right angle, then you would call that perpendicular. Okay, and that would be a 90-degree angle there. Help you figure some of those lines out. Now, this one was kind of tricky for you guys, so I'll spend a little bit of time on it when we're looking at parallel lines. Let me erase this so I can do something a little bit bigger here. Okay. So when we had parallel lines and then we had a transversal line that intersected both of the parallel lines, there were some things that happened to all of the angles that are formed. Okay? And the first kind of angles are alternate interior angles. Okay? So alternate means across from. So if I say I want you to alternate positions, then I would go to someone else's position and then we would alternate. So I'm kind of crossing the line. So when we say alternate, we want to cross the line. Okay? So we have alternate interior. So I want you to think this is inside or interior, and this is exterior or outside. Okay? So alternate interior angles are equal. So what does that tell us? Okay? It tells us that this angle, if I alternate and go interior, these are alternate interior angles and they're equal. Okay, so I'm going to go ahead and just put a little line there so that you can see that the alternate interior angles are equal. But there's also another set of alternate interior angles that are equal. This is an interior angle, so it's equal to its alternate interior angle. Okay? Okay, so these purple ones are the same, and these black angles are the same. Okay? Alternate exterior angles are the same. Okay? So, let me do this with my blue here. This is an exterior or outside of our little house we've made of our parallel lines. So this is an alternate exterior angle. And so we want to alternate, and then we want to go down to find its alternate exterior. So alternate interior angles, alternate exterior. So where's that last alternate exterior angle that you see? Right here. Okay. Alternate exterior angles. Okay, so you can see that those are equal. But let's look at something that I want you to see really quickly. Do you see that this angle and this angle are also vertical angles? So what does that tell me? That the green ones are equal to the black ones. Do you see that? And what else can we see? That the blue and purple angles are equal. Okay? So what does that tell us? It tells us about what we call complementary angles. So complementary angles are basically if I picked this line up and I laid it on this line, which angles complement each other. Okay? So 1 and 1, these complement each other. Okay? These are complementary angles. Okay? Which angle is exactly the same as this angle if we were to lay them on top? These two. They complement each other, don't they? Okay? These two are complementary angles, and these two are complementary angles. So if you're confused about that, there's a really good chart for it. I believe it's on page 493 that shows you the different kinds of angles, but I hope that refreshed for you and gave you an idea. It's really cool when I find this angle, and I know that these two are going to be the same, and these two, because these are parallel, then these are the same, these are the same. It's really neat. So again, you can find one angle. You'll get really good at this in geometry, and you can figure out everything else. So I see some supplementary angles going on in there. So we have a lot of geometry going on within that figure. Okay. So if I were to tell you that this angle, this purple angle, was 110 degrees, can you tell me what every other angle is? Absolutely. If this one's 110 degrees, then I can know that my alternate interior angle is 110 degrees. Okay? I can know that my vertical angle is 110 degrees. I can know that the alternating exterior angle is 110 degrees, which is also a vertical angle. Okay? These are also complementary, so I check those to make sure they're all the same. Then I see that this is a supplementary angle to this one, so the two of these have to equal 180 degrees. Okay, so 180 minus 110 is 70. So I know that this one is 70 degrees. So my alternate interior is 70 degrees. My vertical angle is 70 degrees, right? My alternate exterior angle is 70 degrees. Okay, so I was able to take one measurement and go ahead and fill all these in. Now, will this work if these lines are not parallel? No, that's really important, and it's the basis for getting started in this geometry. Okay. The next thing we talked about were polygons. Remember, polygons are flat, they're closed shapes, and they have to have straight sides. Okay, so I think you remember that. Look in 12.3 if you need to review that. And remember, polygons are labeled by their sides. So a triangle, a quadrilateral, a pentagon, hexagon, all of those shapes. Now remember the difference between regular and irregular. Regular means that they have all of the same sides that are equal. So when I think of a stop sign, I think each little part is the same. It's a regular shape. Now, could I draw an 8-sided octagon shape that all the sides are not the same? I could. And that'd be a really funny looking shape, and we would call that irregular. So the difference between regular and irregular. Okay, we're going to hop back to, speaking of polygons, talking about triangles. And remember, there are two different ways you can label a triangle. You can label a triangle whether it is by its legs, right, by the outside of it. And if we did that, then we would say if all the sides are exactly the same length, we would call this an equilateral triangle. An equilateral triangle. If two sides are the same length, but not the third, we call it an isosceles triangle. Okay? And if none of the sides, this one's always harder to draw, are the same length, then we would call it a scalene triangle. Okay? So that's if we're looking at the outsides of the triangle. Now remember what happens if we're looking to the inside. Every triangle has two acute angles. So we're actually looking for what is the third angle. If the third angle is acute, then it's acute. If the third angle is obtuse, then it becomes an obtuse triangle. And if the third angle is right, it's a right triangle. And that's how we label those with their measurements as well. And you can find those on page 501 if you need to review those. The last one, we started talking about perimeter and circumference. Okay, so perimeter, remember, is the measurement that goes around the outside. Okay, so right now we're building a pig pen for our 4-H pigs. So we needed to find out how big we needed our pen, and then we had to measure around the outside to see how many fence panels we needed to put up around it. Okay, that's perimeter. I'm not worried about how much dirt or how much grass or that is on the inside. I'm just measuring around the outside, the rim or the perimeter, right? So we're adding up each of the sides. We add them all together. Okay, I think you guys are pretty familiar with that, or should be at this point. Now, one of the other words that we learned that I think you're familiar with, but it's a little bit trickier, is circumference. Now, circumference still measures the outside, but it actually measures the outside of a circle. So, hope you girls remember this. So, perimeter we can use when we have straight sides. So, this we would use perimeter to add up all the sides. But we need to use circumference when we're measuring a circle. Okay? So circumference equals pi times the diameter. That's really small. Let me write that bigger for you. So remember, circumference equals pi d. And remember, d is the diameter. So let's look at our circle and let's break that down. Remember, a radius is halfway across, but a diameter actually goes all the way across. Okay, so let's just say this one is 2. Then we would know that this whole thing across would be what? 4. Okay, so if we wanted to find the circumference of this circle, we would say the circumference equals pi times 4. Okay, now you remember what pi is? Okay, remember that pi, the number we can use for pi is 3.14. So we would say 3.14 times 4 will give us our circumference. Okay, and you can pop that in to your calculator. All right. I believe the last thing I want to go over with you are our special right triangles. This is a lot of information. I'm really glad that we're reviewing it today. I could use the review as well. So let's look, let me erase this. And let's look at our special triangles. I'm hoping that a little bit of review will kind of make it come back to you. But again, don't hesitate to ask and use it as a worksheet to work through if I missed something in this short review that I'm doing. So a special right triangle, we have 2 special right triangles that have certain rules. The first special right triangle is a 45-45 right triangle. So let me draw it here. So, it'll look something like this. So what it means by a 45 right. So it's a special right triangle, so we know that at least one of the angles has to be 90 degrees to meet our right triangle criteria. And that means that my other 2 angles are 45 degrees and 45 degrees. Well, once we know that, there are some certain rules that apply to the outside lengths of the triangle. Okay? So if you'll remember, this one is x, and this one is x. Okay? We're going to know that these side lengths are exactly the same length. Okay? If you look at that, it's also an isosceles triangle. Now, this third one will always fit this rule. It'll be x square root of 2. So, if I gave you this triangle, and I said this is a 45-45 right triangle, and this side is 2, can you tell me what the hypotenuse is to the triangle? You would say, sure. I'm going to put my 2 in for x that I have here, square root of 2. And I can tell you that this side is 2 as well. Okay? So that's a 45-45 right. Probably wouldn't hurt to make a note of this, or you can find it in your book. That one's on page 520. Okay? The other kind of special right triangle is a 30-60 right triangle. Let me do it over here. Okay, so it's a 30-60 right triangle, or I would call it a 30-60-90, because we know that this one's 90 degrees. It's going to be something like this. Okay, a scaling triangle. So when we look at it, in this case, this one's 60 degrees, and this one's 30 degrees. Okay, notice in this case that the shorter leg goes to 60 degrees, and the longer leg goes to 30 degrees. You can also look at this one in your book on page 522. But the one that goes to 60 degrees is going to be our x. This leg is going to be x square root of 3. And our hypotenuse is going to be 2x. Okay, so pay really close attention to where you put these. So from the 90 to the 60 degree, because you know the triangle could turn on you, so make sure you're paying attention, is x square root of 3, and 2x. Okay? So if I were to tell you that in this case, x equals 3, okay, then we would say, okay, well this side is 3, this side is 3 square root of 3, and this one is 2 times 3 is 6. And that would give us the leg lengths of each one of these triangles. Okay, so I hope that gives you a good review. The next one, the next section is symmetry, transformations, the line of symmetry, putting things on a graph, coordinating it. You girls had that really well. I don't think that you need a review on that, although I'm very happy to help you do that if you need that. But I think we'll stop from there. That brings us almost to the end of that chapter 12, and it's a lot to listen to. We've been going for 25 minutes. So we'll stop there. Marco Polo me with your questions, and I will get back to you. So I'm happy to help. Don't be shy. I took the brave step of getting on here and making these videos, and so you can do it too. Okay, talk to you soon, girls.